Hello, I'm Hedy Park, a graduate course researcher at Hansen University. The title of the paper is a study on the analysis of operation, concept, and scenario of small UAVs, and we researched with Professor Jae-Hyung Park, Min-Seok Ji, and Won-Hyuk Choi from the same university and write this paper. First, let me tell you about the background that started this study. According to domestic law, service providers such as air transport business operators, aircraft maintenance company, air traffic service providers, airport operators, and navigation safety facility installers are notified in order to achieve the safety targets suggested by the Minister of Land, Infrastructure and Transport for safety activities in the relevant business field. It states that safety and indicators should be set and managed based on the established common safety indicators. However, if the safe of UAV operated without pilots on board, research has not been conducted in Korea, including the RPAS UAV discussed in ICAO, as well as small UAV operated within non-regulatory zones, such as identifying hazard by emission or MEL. Therefore, in order to secure operational safety of UAV and to establish minimum stability and indicators, it's necessary to establish representative mission models for UAV, identify operating concepts and MEL for each mission models, and identify and analyze the corresponding threat and hazard. For this study, it's necessary to classify UAV according to the user's operating needs and to establish a system to determine the level of safety that is appropriate for the classification. Therefore, in this study, the UAV classification system, simplified by domestic statutes, was defined in detail to meet the global trend. The representative tests were set, including BLOS operation for UAVs that required the measurement and accumulation of quantitative safety data for safety measurement, and standardized operation scenario was presented. Along the research method, I will first tell you how the classification of drones and the establishment of the operating concept were conducted. Looking at Table 1, the range of UAV that have legal effect in Korea can be divided into UAV weighing less than 150 kilograms and more than 150 kilograms under the Aviation Safety Act. Others are classified based on 12 kg on the Drone Safety Measurement System in Table 2, based on whether or not a vehicle is registered and whether flight approval is required. Therefore, the classification of UAVs and drones is not clear, and it can be said that it encompasses a variety of UAVs that do not have a pilot on board. Let's look at the overseas UAV classification system. The countries that can be considered as advanced drone countries are the United States, Australia, and the European Union. In the case of overseas drone advanced countries, UAVs over 150 kg are classified according to ICAO-defined RPAS type UAVs. In the case of Australia, since it was initially an act to operate small military drones, it was difficult to apply directly to the analysis and was excluded from our analysis. Let's see America first. The classification system for drones in the United States is defined based on the FAA Pathfinder program and UAV registration program introduced in 2015. The FAA Airspace Safety Operation Policy accepts aircraft registration as much as possible, but applies the concept of aircraft operation within a certain level of safety. Under these principles, the FAA classifies airspace into low population and densely populated areas that can be caused third-party damage. Accordingly, the operation of drones began by piloting drones flying in the visible and invisible areas respectively. As a result, the U.S. classified small UAVs from 250 grams to 25 kilograms. Refer to Table 3 for detailed drone classification. The AIS Grade 3 used in Table 2 is an abbreviated injury scale based on the anatomy-based coding system proposed by the American Association for the Advancement of Automotive Medicine, and refers to the life-threatening grade representing the victim's condition in an accident. See Table 4. However, the U.S. classification system is difficult to simulate secondary damage caused by drones, and there are limitations in specifying regulation or operating limits for aircraft. Therefore, in 2016, small UAV regulations were newly established and enacted, allowing commercial activities and operation using small drones. The European Union's drone classification was developed to apply to the protection of personal information caused by the operation of drones, compensation for damage in case of accidents, and product reliability for consumer protection. UAV weighing more than 150 kg and less than 150 kg are classified, and based on these new regulations of the European Union's aviation, authorities are established to coordinate the details, and policy relative to safe operation are being implemented. EASA's drone classification system classified small UAVs under 25 kilograms into 5 levels, from Class C0 to C4, and stimulate that each class of aircraft is registered. See the table for details. At this point, it was determined that the EU is the most standardized regulation for the operation of UAVs. As shown in Table 6, the entire UAV is classified into 3 risk categories: open, specific, and certified according to operational risk. Standard operation scenarios for UAVs have been established for each category, and detailed classifications for each risk category are classified and regulated for each country. However, securing safety in drone operation is not a value that can be capped by simply specifying and regulating the limits of drone operation. The factors and risks that cause drone accidents are manifested by various factors, such as the safety of the drone design, the stability of the operator's education, and the appropriateness of the license system. The risk of damage after manifestation can also be said to have different consequences depending on the countermeasure. Therefore, the European Union and EASA are applying regulation on drone operation as shown in Table 7 to control accidents in the operation of drones. For details, see Table 7. And the following Figure 2 summarizes the airspace usage, regulations, and operating conditions by risk category of the most commonly used drones. I will introduce the following resource method. Drone operation scenarios were derived based on the missions of drone use projects that differ greatly in the form, operating area, environment, and operating airspace of drones, and the required drone equipment configuration, airspace requirements, and operational singularities were analyzed. Three missions models were set: diagnosing facility safety, collecting of evidence for violation of highway regulation, and shooting event venue. I will tell you in turn. This mission was defined as checking for cracks and damage of facilities using a vertical takeoff and landing drone equipped with a gimbal for posture stability. The main objects are limited to facilities such as bridge, communication towers, solar power plants, power transmission lines, and transmission towers that have few people around and can be controlled. The operating concept is as specified in the table below. Depending on the drone class, this mission assumed that a 2050 kg C3 class drone with the features mentioned in the table of the specific category will be operated. The required airspace complied with the standards for non-control altitude set out in the current legislation, reporting altitudes below 400 feet and permitting more than 400 feet required by EASA's specific category drone operation. Expected accidents and damage objects are also listed in the table, so please refer to them. The operation procedure of drones disguised as VLOS and BVLOS operation is defined in 9 steps as follows. In the performance of the mission, it was assumed that the operator must be operated together by 2 or more operators with a control license. This mission was defined as using a drone equipped with a posture stabilization gimbal to fly long distance in a specific space, monitor traffic violation and film violation. Refer to the table for mission performance areas and limited to areas restricted to operation due to the nature of exposure of people, such as rest areas and toll gates. Due to the nature of shooting violation, it assumes that the drone has the operating characteristic of high-speed flight of 100 km per hour level for a long time, and the drone's taking off and landing on the shoulder. The operating concept is as specified in the table below. Depending on the drone class, it's assumed that this mission has the operating standards of the specific category, and 25 kg C3 class drone or C2, C3 class fixed wing drone with the functions mentioned in the table is operated. The required airspace complied with the standards for non-control altitude set out in the current legislation, reporting altitude below 400 feet and permitting more than 400 feet required by EASA's specific category drone operation. Expected accident and damage objects are also listed in the table, so please refer to them. The operation procedure of drone disguised as VLOS and VLOS operation types is defined in 8 steps as follows. In the performance of the missions, it was assumed that the operator must be operated together by 2 or more operators with a control license. This mission was defined as the use of a drone equipped with a posture stabilization symbol to repeatedly fly and hover in a specific space to photograph the main situations of the event venue. Refer to the table for the mission area, and the drone is limited to VLOS only. In accordance with the Aviation Safety Act and its enforcement regulations, flying over densely populated areas must obtain flight approval for its flight. Therefore, the operating concept was established based on the flight approval for the mission as well. The operating concept is as specified in the table below. In this mission, there's the special event in which the ground damaged object is not able to pay attention to the drones as a general crowd. So a flight method that can reduce the risk of ground damage must be defined. Drones for this mission were presented by dividing into commercial drones and personal shooting drones. And commercial shooting drones were limited to 25 kg C3 class multicopter drones with high stability because the result of shooting should have commercial value. In the case of personal drones, it's assumed that C2 class drones with the function mentioned in the table are operated with the operating standards of the specific category. The required airspace is assumed in consideration of the operation in densely populated areas and the prevention of accidents caused by collision with facilities. Expected accident and damage objects are also listed in the table, so please refer to them. The operation procedure of the drone disguised as a VLOS operation type is defined in 6 steps as follows. In the performance of the mission, it was assumed that the operator must be operated together by 2 or more operators with a control license. In summary, in this study, the classification system of UAV in Korea was redefined and a mission model was selected to ensure minimum safety of UAV in uncontrolled zones. The concept of operation for this was also described. Accordingly, by driving operational scenarios for its mission, we predict the type of accidents that could occur and the victims. In the future, as research that can be developed based on this research, there will be research to identify the types of accidents that may occur in the operation of drones according to scenarios based on the derived operational scenarios. In addition, this operational scenario will be used to analyze the hazard that may cause the accidents identified based on the PBS of the drone system and the cost of hazard. Also, risk assessment will be conducted for each mission scenario based on the bow-tie table for each hazard notified by the Ministry of Land, Infrastructure and Transport. That's all for my research. Thank you for listening.